Really want to get that first shuttle flight in today. We got to do the test flight to make sure that make sure it works fine in mission mode. How many gifted subs today?
Go at throttle up.
I don't know, man. I lost count. There's bits and subs and tips in there. It's just...
Discovery, go at throttle up.
There's a lot. Are we getting an SDS-1 today? I want to do that, yeah. I mean...
Discovery, go at throttle up.
You can tally it up, but I don't like doing that. I don't even like doing that because it's like...
Discovery, go at throttle up.
Level 5 completed. I don't even like doing that because announcing it is just going to make people tip more. Like,
Discovery, go at throttle
it's not how I roll, guys. New all-time record, 26. You know
Discovery, go at throttle up.
what? 131.
Discovery, go at throttle up.
Nice. All right. Next time it'll get me to 154. Yeah. Next time. Okay. All right. So this is the VA259 Ariane 5 launch. This is launching Galaxy 35 and 36. They're two geostationary communication satellites for, I believe Galaxy 35 is an Intelsat. Third to last flight of the Ariane 5. Let's celebrate. Yeah. Do they have a replacement? They do. Yeah, Ariane 6 is coming next year. Here, I'll show you that real quick while we're... Yeah, that thing. That's just a mock-up, though. It's only a model. Okay. I just want to go over here. Let me see. So that's those are inerted boosters. This is basically just that's the mass simulator. Well, not a mass simulator. It's a integration flight test article. So the real stuff is not there yet. It's going to be there soon. But yeah, that's Ariane 6. Ariane 6 is similar to Ariane 5, but instead of having 2 SRBs, they can have up to 4. And these solid rocket motors that they have on the side are P120C. They're P120C motors. Those are Vega's first stage. There's 4 of them, which is pretty cool. It's a pretty cool rocket. But yeah, Ariane 5 is the one that's right there in the center. A very similar style core stage, but this one only has 2 boosters on it. Ariane 5, Atlas 5, Delta 4 Heavy all coming to an end, the end of an era. Yep. Specifically, this is the Ariane 6.4 configuration. The Ariane 6.2 configuration only has 2 SRBs. Yep. That's why I said it can have up to 4. So let's jump back in here. So Ariane 5 is going to launch out of the Kourou launch site in French Guiana in South America. They use that because there's not really Europe is too there's too many people on continental Europe to have really a good launch site, and ideally you want your launch sites with ocean facing to the east, which the few places that do have launch sites that are favorable to those conditions really have way too many people. Or it's over a really, really big shipping lane. Down there in South America, in French territory, so French Guiana, there's not a lot of people out there, and it's not that... You have a big Atlantic Ocean, basically, to the east. So they... this is where the European Space Program does operate, and they've been operating out of here since the 70s. Sad to see the old veterans go, but excited to see the next gens. Yeah, it's the circle of life, guys. It happens. Apparently, it's supposed to be cheaper to compete with SpaceX. Well, they did secure a block buy with Project Kuiper for Blue Origin, Red Fox, so... I mean, I think that Ariane 6 will bring down the costs, but it really... My honest thing is that I don't know how long it's going to do that. I don't know how long it's going to do it. Especially with reusability on the table, you know, but who knows? Remember, guys, what drives the launch market is demand. The demand drives the launch market. So if there's no demand, it doesn't matter if you have a rocket that can fly all the way up into space and come back down in one shot, fully reusable, like a fully reusable SSTO. That doesn't really matter. If nobody wants to put anything on it, then, you know, it'll be deemed a waste of money, you know? So the demand, fortunately for us, is going up. And bridging the demand with commercial launches, when I say bridging, there's a very specific thing that I'm getting into. Like, so bridging the demand, there's a certain market demand here. Bridging the demand between spikes in demand is really what's going to normalize launching rockets into space, like, you know, as much as we fly airplanes around. Now, what do I mean bridging it? So the demand in the rocket market, or in the need to launch payload into space, is very sinusoidal. So it goes up and down. There are ebbs and flows to it. Basically, every 10 to 15 years, the launch market demand basically was going to zero. It's basically been like this since the 80s, 90s, somewhere around there. The reason why is because in the 90s, the commercial markets were exploding. They were exploding just like they are now, or just like they were now. And the reason why they were is because the dot-com era allowed people to finally, and, you know, kind of the electronic and tech revolution basically made it so people could afford to make satellite constellations, big constellations and big telecommunications satellites. And everybody launched all their stuff into the mid to late 90s. And then the dot-com bubble happened and demand went to... But it's interesting because the demand went to virtually nothing, but it wasn't entirely because of the dot-com bubble bursting in 97. It did have something to do with it. But honestly, the shelf life of the satellites is 10 to 15 years. So you go into the late 90s, everybody launches their satellites, their networks are good, they're going to be good for another 10 to 15 years. So we didn't really see a big spike in demand for commercial satellites until 2015, 2016. And that's when we started to see the demand go back up again. And then even then, the demand is still going back down. It's still going back down because everybody's putting their satellites up there. So but there's been a buck in that trend. The buck of that trend is, believe it or not, it's commercial small sat launching. So launching smaller satellites that are more inexpensive to launch, right? Launching smaller satellites that are more inexpensive to launch more frequently. That is kind of bridging the demand and making the amplitude of demand for these waves kind of level off. That's the real big thing that we're seeing right now. Yeah, I mean, Aqualux, yeah, if you want to attribute it to that. Yep. The satellites are going to lower orbits. They're not as big and they don't last as long. That ends up being a net cheaper option than building one gigantic big satellite that's designed to stay up there for a couple of decades. I did, Gujar, yeah. They did fusion at Livermore. So, and that's what I mean about Ariane 6. I'm not 100% sure if Ariane 6 is going to... It'll work in the interim, but they're going to need to develop some type of reusable solution to help bridge the demand because, you know, these small sat networks, they need to be maintained, like Starlink, for instance. I'll use Starlink. Starlink satellites only have a shelf life up there about 5 years. The first Starlink satellites that were launched are already long gone. I'm talking about the test satellites that SpaceX launched in 2017, I think. Those are long gone. Yeah, they ran out of propellant in their orbit decay, but they're very inexpensive to launch, so you can launch a lot of them. Internet satellite constellations are basically bridging that demand, and we have a ton of demand for this type of thing. You have OneWeb, you have Starlink, you have Project Kuiper from Amazon. There is a lot of demand for this, and that type of launch frequency is going to demand a more reusable vehicle because we're getting away from gigantic big satellites being launched to more small satellites being launched in a rideshare, like all together. So because of that, like that favors reusability because you're launching more frequently. Nothing favored reusability before except because you were only launching like 4 to 5 times a year with a huge satellite. And even then, after that 4 to 5 times a year only comes around every decade or so. So, I mean, you're seeing a huge paradigm shift in the launch market. So I think Ariane 6 will be competitive on cost for a little while. But if the demand keeps going up because these satellite networks need to be constantly maintained because the shelf life of the satellites is lower, that does favor a reusable option. You either simplify your vehicle design to be really, really easy to manufacture and expendable, or complicate the design and move to a more reusable style system. Or find a hybrid solution, which is basically what ULA is doing. I'd launch my own EU-based satellite internet if you had the money. Yeah. All right, let's see what they got planned here. We have Road to Space. I mean, that sounds like a you problem, Alex. I mean, adapt or get left in the dust, dude.
Hello, and a very warm welcome to worldwide audiences joining us today on Road to Space for flight VA259, baptized tonight State of the Art. Why? Because for Ariane 5's last flight of the year, its fairing will be adorned with a very original piece of art. But not only, the European launcher, which is taking off in approximately 20 minutes from Europe's spaceport in Kourou, has underneath its fairing 3 very special passengers on board. MTG I-1, the new Meteosat third-generation imager built in partnership with ESA. It's a remarkable satellite built by Thales Alenia Space, which will revolutionize weather forecasting. And of course, Galaxy 35 and Galaxy 36, built by Maxar for Intelsat, 2 C-band telecom satellites that will provide Intelsat media customers in North America with contribution capacity to support high-profile events such as professional wrestling, boxing, auto racing, golf, baseball, and collegiate, and professional football.
You guys
we will, of course,
baseball?
be talking to you in depth about these special passengers. But before we go any further, everybody, let's head over to the Jupiter control room where Stefan Israel, Arianespace's CEO, is waiting for us. He should be coming up on the screen any minute. Just here we go. Hello, Stefan, and welcome to Road to Space.
Good afternoon.
Good afternoon. So, Stefan, today's mission is for 2 very well-known customers of Arianespace, EUMETSAT and Intelsat. What can you tell us about this mission today?
Yes, so about our customers, EUMETSAT will embark for the 14th time with us for MTG I1 and with a very important partner as well, Thales Arianespace. It will be the 167th satellite we will orbit for Thales Arianespace. And regarding Intelsat, our partnership has started in 1983, and Galaxy 35 and 36 will be the 63 and 64th satellite we will orbit. And Maxar, also a very important partner, it will be the 69 and 70 satellite we will orbit with Maxar. So you see, it is an old family of friends we will orbit tonight.
And an incredible track record. But what feels so special about tonight's launch, Stéphane?
Yes, two things are very special tonight. It is for the third time the fact that we deliver an Ariane 5 in triple configuration. In upper position, we have the stack of Intelsat with Galaxy 35 and Galaxy 36. And in the lower position, we have the MTG I1 satellite. So this is the first specificity. And the second one, this Ariane 5 has an overall performance of 10 tons, 972 kilos. It is the second more performant Ariane 5 we have ever launched.
And can you tell us how the mission will unfold?
Yes, so we are now a few minutes before the launch. All the parameters are green, the satellites are ready, the launcher is ready, the weather is green. So at 5:30 we will lift off, and the mission duration will be 34 minutes. We will first separate Galaxy 35 and 36 after 27 and 30 minutes, and then we will separate MTG after 34 minutes. And now we are just waiting for the final countdown for the liftoff.
Well, thank you, Stéphane, so much, and good luck with everything. We'll speak to you later. Well, we have a packed program for you tonight in Kourou, but now let's welcome Raphaël Chevrier, Business Developer Innovation from Arianespace, and Mathieu Chaise from Ariane Programs at Ariane Group. Good evening to you both. So happy to see you both. Welcome back to Road to Space.
Good evening, Emma.
Good evening.
Mathieu, you will be talking to us essentially about the Ariane rocket, and you, Raphael, of course, will be helping us understand the finer details of tonight's flight. So to kick off tonight's proceedings, we have put together some images of the different stages of flight VA259. So, Raphael, I would like you to comment on them, please.
Yeah, of course. As Ariane 5 is sitting now on its launch pad in French Guiana, as we can see on the image, what we will see first is the ignition of the main stage, engine Vulcan, for about 7 seconds. I think the video is going to be displayed before the two lateral boosters actually ignite and the rocket soars into the sky.
Here we have the images.
Yeah, so only 2 minutes and 21 seconds after liftoff, the two boosters have done their job of providing the main thrust, and they are detached from the launcher. Shortly after that, we separate the fairing as we have crossed the limits of the atmosphere, and we don't need to protect the satellites from the friction of the air anymore. Once the main stage has put the launcher on an intermediate orbit, it is also detached, and we enter what we call the second propelled phase of the flight with the ignition of the upper stage engine. It powers for about 16 minutes in order to raise speed, altitude, and to reach the transfer orbit, where the satellites are released. At this stage, the whole assembly is going to weight only 2% of the launcher's initial mass. And after some orientation maneuvers, we first separate the upper passengers. So first Galaxy 35 and then Galaxy 36, so one after the other. The little towers that we see on the motion pictures represent a chain of telemetry stations receiving data from Ariane 5 all along the flight path. Then we separate the dual launch structure SILDA before releasing the lower passenger MTG I1. And then exactly like in a relay race, we pass the baton to the customers who will perform all the maneuvers necessary to get the satellites into their final geostationary orbit. And this is not really the end of the mission for Arianespace, because we perform what we call a passivation of the upper stage, meaning that the remaining propellant of the tanks is expelled in order to prevent any risk of explosion in space. And once it's done, we can call it a mission terminated. mission done.
Thank you, Raphael. So in less than 30 minutes, Ariane 5 will lift off from Kourou with all the teams who will be completely focused on the progression of this mission. We will have the privilege of gaining access to the temple of this spaceport, the Jupiter Control Room, the place where the launch operations are managed. And here with us tonight, we can see perhaps up on the screen representatives from the different space companies directly involved with tonight's mission. We have André Hubert Roussel, CEO of Ariane Group, I trust this is him up on the screen. Yes, I'm right. Hello, Mr. Daniel Nieuwenschandaer, Director of Space Transportation at ESA, who is up on the screen. And of course, Marianne Claire, Director of the Guyana Space Center. There she is, Directrice du CSG. Okay, so today's launch continues Intelsat's Galaxy fleet refresh plan, which began with Galaxy 30 in 2020 and carries the third pair of satellites launched over the last few years. These assets will provide occasional services to cover North America. We will learn more about these two very special passengers on board in the following report. So see you in a couple of minutes on Road to Space. We'll be back afterwards. More entertainment aimed at North America. Galaxy 35 and Galaxy 36 will soon provide high-performance media contribution capabilities and support live event coverage for Intelsat customers.
Our video neighborhoods around the world reach 2 billion viewers. These are 2 billion people who are informed, entertained, educated, and inspired by the content we bring to them on behalf of our customers.
Launched aboard Ariane 5, the two geostationary communication satellites are part of Intelsat's Galaxy fleet refresh plan that started with Galaxy 30, also launched on an Ariane 5 rocket back in 2020. As the newest additions to Intelsat's Galaxy fleet, Galaxy 35 and 36 will contribute to the most efficient media distribution system in North America. The Galaxy 35 and Galaxy 36 satellites will bring C-band contribution capacity to support high-profile events such as collegiate and professional football, auto racing, baseball, golf, boxing, and professional wrestling.
It really takes a lot of people and a lot of companies to design, build, test, launch, and then operate a satellite. We're very fortunate. We have some of the best people in the industry, and everybody contributed to this big success.
Built on Maxar's 1300 class bus, one of the most trusted commercial spacecraft platform and backed by Maxar's 60-plus years in satellite manufacturing, these two new satellites support Intelsat's successful, uninterrupted transition in the C-band spectrum, and Maxar's commitment to customer success and improving life on Earth. Well, in less than 15 minutes, Galaxy 35 and 36, the two satellites designed by Maxar for Intelsat, will launch into space on board Ariane 5. Arianespace has been working with Intelsat since the beginning of Ariane right through to Ariane 5. And soon, Ariane 6, a remarkably long-standing partnership, Raphael.
Yeah, I mean, the teams are very used to work together. As a matter of fact, there is one Intelsat operator, I've been told, that is working on this campaign, and he was already there in 1983 on the first launch of an Intelsat satellite on an Ariane. And since then, we have launched on 60 different launchers. Intelsat satellites. So that's one launch every 8 months.
Incredible figure.
And it's not going to be stopped because we have announced the signature of a new launch contract on Ariane 6 to launch 2 Intelsat satellites, 41 and 44.
Well, we will also be bringing you news of Ariane 6 later in the program, but for now, let's stay focused on tonight's mission. Well, we've just been introduced to the two Intelsat passengers, but as you know, they are not the only passengers on board Ariane 5 tonight. Their fellow traveler is, how might I describe him? Well, he is really quite remarkable. Designed in the south of France by Thales Alenia Space, MTG-I1 is the first of 6 new generation satellites designed to revolutionize weather forecasting for EUMETSAT. To find out more about him, let's watch this next report. As the threat of extreme weather events is increasing, accurate weather forecasting and nowcasting is now more important than ever. What if the most complex geostationary system ever launched could help predict storms, save lives and safeguard goods? This is the mission of MTGI-1 that will take off from Europe's spaceport today on Ariane 5. A highly anticipated launch for the very first Meteosat third-generation constellation satellite operated by the European operator EUMETSAT. It is developed by the European Space Agency with Thales Alenia Space and more than 100 entities from all over Europe. A true symbol of team effort and dedication, of cutting-edge technology and innovation, this heralds a brand new era for weather forecasting.
This new generation is important, first of all, to guarantee continuity of data for a long period of time, to support users, not only public users, but everybody. Everybody means every citizen today, with more accurate information, with more spatial resolution, with more timely information for the relevance of the daily use of everybody.
Meteosat is part of our DNA at Thales Alenia Space. We have been the trusted prime contractor for all the Meteosat satellites since the 70s. Meteosat first, second generation, and now third generation. Through Meteosat, Europe supplies the best meteorological satellites in the world, thanks to ESA and EUMETSAT, and plays a major role in world weather forecast. Our teams at Thales Alenia Space are extremely proud to be part of this success story alongside with OHB and all other contributors.
These third-generation weather satellites will revolutionize nowcasting of weather in Europe and Africa by helping storm prediction and enhance weather forecasts.
MTGI, and in due course the full MTGI programme, will be critically important for supporting nowcasting. Nowcasting is the forecasting over a short period of time, up to 6 hours, which is most important for intense, localised events, which in reality are very difficult to forecast on longer timescales.
The major thing that the MTG does is do that. It picks up major storms in their infancy, so we can actually take the necessary steps to ensure safety of life, prepare for the deluge that might happen.
The social and economic benefits of accurate forecasts are huge, and this is largely thanks to satellites.
Weather, and particularly severe weather events, take a huge toll on European society. In fact, in a recent survey of its members, the World Economic Forum identified that the key risks that countries see themselves as facing over the next 10 years are severe weather events and the failure to respond adequately to climate change.
ESA and EUMETSAT have been working together for over 4 decades to maintain Europe as a leader in satellite meteorology. MTGI-1 will shortly be joined by 2 other EUMETSAT satellites, MTGS-1 and MTGI-2. Together, they will provide essential weather and climate data for the next 2 decades to come. We'll come back to this highly sophisticated satellite later on in the program. In the meantime, I would like to focus on our launcher, Ariane 5, because tonight Ariane 5 will make its 3rd flight of the year, and also, guys, one of its last. The first ever flight over 25 years ago. So this means Ariane has been in operation for, what, a quarter of a century, Mathieu? How would you sum up this heavy launcher, and for you, what memories will she leave behind? I say she.
No, it's impossible to summarize what is Ariane 5, but you have to remember it's a European success story made possible by 12 contributing countries with institutions, agencies, and of course, industry with unique competencies all over Europe. And if you look just at the performances, tonight we're about to launch 11 tons towards a very energetic orbit, since we reach a velocity that's above 33,000 km per hour. So just one memory, this launcher is the one that allowed the first images we got from the James Webb Telescope, for instance.
Can I ask you also, what can you tell us about her evolution? She's obviously evolved a lot since her first mission.
Yes, that's really in the DNA of Ariane 5 and actually the Ariane family to be evolving in an incremental way. If you compare actually the launcher we have tonight on the launch pad with the first version of Ariane 5, we almost gained 5 tons of performance. So it went through the introduction of new engines with the introduction of Vulcan 2 evolutions on the upper stage with the cryotechnic upper stage, but also storable propellant at one point that allowed Galileo or ATV missions. So yes, that's really always a principle to push the limits as much as possible to be able to serve any mission.
We're now 30 seconds away from the DDO announcing the synchronized sequence. Yeah. The DDO is obviously the Range Operations Director. He will be announcing the synchronized sequence, and I would just like to ask you before this, you two, if you can explain what it is.
It's a last crucial step. It's a succession of operations aimed at giving more and more autonomy to the launcher. And for this, everything that you see on the board needs to remain green. The space base, the launch vehicle.
Attention pour la séquence finale lanceur.
So the DDO is about to
Top, H0-7 minutes.
T-minus 7
so
minutes.
You see that everything is green, so the synchronous sequence has started.
Yes,
the countdown has commenced.
Yes, this is really the ideal situation in which you want to be. Everything is green. So what does it mean to give autonomy to the launcher? So we'll do the final steps to put it exactly in a flight configuration, which means the final loading of the tanks, the topping, as we say, also the pressurization of the tanks, and a few minutes, 3 minutes before launch, we'll give the launcher the exact date, time of the launch.
And as we want that, of course, 100% of all the parameters remain green, if one turns red during this synchronous sequence, then the clock will be set back to 7 minutes before the launch. Of course, we don't take any risk. We don't leave anything by chance.
What kind of problem could stop this synchronized sequence?
Well, I mean, like I said, like all the parameters that you see
could
turn red. For example, if there is one telemetry station that is used to follow the launcher during the flight, if it has an issue, then we need to fix it before actually launching, of course. We are checking all the safety means, make sure that it's in place in order to actually authorize the launch. Need to check that there is no issue on the satellites, of course, on the launcher, on the space base. So right now everything is red, so we should be able to continue the countdown.
Well, before that, we're obviously watching Road to Space, and now we have some images from the events of the launch campaign in front of us, which are coming up on the screen at the moment. If you, Raphael or Mathieu, you could comment on them, please, because we're waiting.
The campaign started a month ago when the stages were shipped from our facilities from our group in Les Mureaux and Bremen towards Kourou. There you see the main cryogenic space that's getting out of its container, and then the boosters, each one of them holding 240 tons of solid propellant. And then the upper stage has been mated on top, and once this assembly is ready, you can move to another building so that the launcher meets the satellites.
So so talking about the satellites, the MTG-I1 satellite arrived in French Guiana last October by boat. Also, it was transferred to preparation facilities where actually many operations are done. Satellites is removed from its container. It is integrated on its adapter. It is fueled. And like you see, these are very careful operations. On the other hand, the Galaxy 35 and Galaxy 36 arrived in late October, November, respectively, by plane in Cayenne. They were transferred in a special container by road to the Guiana Space Center in Kourou. Both satellites are also removed from the containers in clean rooms. They are carefully inspected. You saw it like turning on itself. You can see on the images the size of the operators. That's quite impressive. You can see the size of the satellites next to it. It's always a bit amazing.
We're talking about spacecrafts that weight 3 tons, 3.6 tons. It's massive.
And so here, they are like checking that everything is perfectly right. And then the satellites are transferred in the final assembly building where they are meeting the launcher finally for the first time.
Yes, so we can actually, you can see Galaxy G36 that's set on the dual launch structure, the SILDA, and the 35 on top. And finally, the fairing is actually installed on this tiered cake. You know, it's like a wedding cake where you put everything together. And MTG in parallel is assembled directly on top of the upper stage.
And then only then, the whole SIDA, Galaxy, and fairing assembly is positioned on top of MTG, right as you see in the images. And I think, yeah, you can see the special drawing, the piece of art on the fairing.
Oh, that's right, I can see it.
It's small, but it's there.
And the final step that you see is when we roll out the launch table and get to the launch pad.
Guys, we are 2 minutes and 35 seconds away. All this hard work will shortly come to fruition when in a few seconds, Ariane 5 will take off on one of its last missions. The 3 passengers on Ariane 5 are a bit like us, impatiently looking forward to this journey into space. They are, of course, the 467th to 469th satellites to take off on board on the Ariane launcher. Well, I imagine the VIPs are now firmly installed on the balcony, guys, with the best view in the house, not only seconds away from liftoff. What can we expect tonight? The last time she took to the skies, I remember it was quite a show.
I mean, it's quite clear, the sky here, so I hope we'll have sort of the same spectacle. We might see the booster separation with our eyes. Maybe like last time we saw the fairing separation. I'm not sure we're going to see it in daylight. It really depends on the clouds and the angle of the camera, but yeah, I have like high hopes for tonight.
I feel that we might be extremely lucky to see all of this.
They're all
events.
running out onto the balcony.
And, yeah, there are some clouds, but you know, from time to time, between 2 clouds, you can see actually these boosters getting separated, and I really hope that we'll get to see these 3 dots in the sky.
Well, Tamara Tezele, the Range Operations Director, is about to announce that we have hit the 1-minute mark before liftoff. Everything is set to go, guys. Best wishes to all the team. So let's sit back and enjoy the show, as they say.
À tout de DDO, attention pour moins 1 minute.
This is the mission director, T-minus 1 minute.
Top, à 0 moins 1 minute.
Your mic's still on, guys. $20 seconds. So you're gonna get main engine ignition at T-minus 0.
À tout de DDO, attention pour le décompte final.
Stand by for the final count.
10,
10,
9,
8,
8, 7, 6, 5, 4, 3, 2, 1, top.
Main engine ignition. Good ignition on the core stage, T+7.
Allumage
Booster ignition.
Allumage des EAP, décollage.
Décollage. She's flying. Nice shot. She gets off the pad real quick.
La propulsion est nominale.
Propulsion is nominal. Camera clicks. We have 3 satellites on board, Galaxy 3536 and MTG, which is a climate monitoring satellite. Oh, great shot. Great shot.
And we are off. How wonderful to see the mighty Ariane roaring across that equatorial sky. Definitely launched a saver.
Oh.
We are now over 1 minute into the flight as she powers her way into space, heading east out over the Atlantic Ocean. Raphael, Mathieu, a reaction?
It's hard to get tired of it, right? I mean,
it's amazing.
I heard it. That was Raph.
I might be an engineer, but still I have emotions when I see that.
That was Raph.
It's like a ball of fire thrusting itself into
and we are extremely lucky because we can clearly see the rocket like blasting its way towards
Raphael,
space.
what do you have to tell us?
Well, I mean, everything is going to happen quite quickly now. you'll have in a few seconds the booster separations.
That's the first thing we have to look out for.
Yeah, they will have provided 90% of the overall thrust in order to literally escape the gravity pull of the Earth.
And with the clear sky, we'll see them well.
I hope so. I think we will. And then you will have the separation of the fairing when we have crossed the limits of the atmosphere. It's protected the satellite from the friction of the air, but also from the noise generated at the booster's ignition.
Booster tail off.
And then we will have the separation of the main cryogenic stage.
Stand by for separation.
And here,
here we go.
And
the booster separation.
Yeah,
we see it so clearly.
We see it.
So it's confirmed visually and also in our...
By the DDO.
By the DDO.
Brilliant.
And okay, so the sky is perfectly clear, so it's perfect conditions to
So, Mathieu, without these two boosters, the launcher is obviously now a lot lighter. So, than it was at takeoff. Its load has been lightened by how many tons, and why is this necessary, even essential? Does lighter mean faster?
Yeah, it was 775 tons on the launch pad. Now it's about 156 tons because we got rid of these empty boosters. Imagine that we managed to get rid of about 500 tons of propellant in about 2 minutes and 20 seconds. But this is the amount of energy that you need to go to space. And this is a principle. You get rid of any useless mass to provide maximum acceleration to the satellites. And now we've got fairing separation.
Fairing separation.
And we actually can see it.
Separation de coiffe.
So we have, again, visually the confirmation and also by the DDO.
That's brilliant news.
We can actually see the two halves of the fairing getting separated. That's magical.
Those images are incredible.
And this is the last time, by the way, we see the piece of art that was on the fairing.
Bye-bye.
Yeah.
Well, thank you, Raphael. As you can see on the screen, computers are generating now perhaps CGI images for us to see what's happening. It will be coming up in a minute. We have 5 minutes, not now, because obviously the skies are so clear, we're seeing everything. We have 5 minutes now before our next milestone. So let's focus on our launcher, Ariane 5. Mathieu, I'm turning to you. Could we come back to the particularities of this heavy launcher? It is the reference in space transportation.
Yes. Internally, we call it the legend.
The legend. the living legend.
Okay, so I'm going to go over to the other side of the screen here. So these right here, obviously that's CG. That's a CG representation of what the vehicle is doing. You're getting shots from their mission control right here. This is the track. That's the ground track for the vehicle here. And then over here, you see downrange distance and altitude. The important thing to keep track of with these launches is, and an important thing to understand, is that this is real time. That's real time telemetry right there. That's literally what these guys see on the screen. Every rocket has a nominal track that it follows. Think like a roller coaster almost, right? There's a nominal track, and don't get me wrong, you get some deviation because of wind and stuff. But the really easy way to figure out if this rocket is following a nominal trajectory is if the center of that X right there is inside of that circle. If the X is inside of the O, that means the vehicle is following a nominal trajectory. If the X goes outside of the O, they've either had a loss of signal, handover between ground stations, or something is wrong.
Discovery, go at throttle.
But this info down here is real time. That's just an animation. This is basically, even if this thing stopped, this animation would still going. It would still be going. It's not a real-time animation. Down here is the stuff that you want to pay attention to. Oh, hey, Guy. Why did they separate the boosters when they're empty? To lose weight? Does that mean lighter? Lighter means faster? Yeah, maybe. I don't know.
California. Mathieu, what is the maximum number of satellites that Ariane 5 can carry? I've seen 1, 2...
Yes,
3.
A typical mission for Ariane 5 would be what we call a dual launch. And actually, the SILDA means dual launch system in French. But tonight we have 3 payloads because we're really capable of adapting this launcher to any needs. If you remember, too, we were able to deploy 4 Galileo satellites when necessary on Ariane 5. So that's really the philosophy I described, adapting the launcher to the customer's needs.
And with Ariane 6, we will have even more flexibility.
Okay, so the rocket is 168 kilometers in altitude, about 100 miles up, 800 kilometers downrange, so we're about 500 miles downrange. Velocity is 4.38 kilometers a second, so 4,400 meters a second, or about 9,000 miles an hour, somewhere in there.
With Ariane 6.
A lot of things to come, and we're looking forward to that. Well, thanks for all those interesting
Propulsion is nominal from the
and fun
mission
facts.
director.
The next important step will be the cutoff of the main core stage, the extinction and the ignition of the upper stage.
Yeah, the ignition of the upper stage is absolutely key for the rest of the mission, and it's always a bit tricky to actually ignite liquid stage in the emptiness of space.
I imagine.
Yeah.
Yes, we're going to go through a series of events, and as you can see, it's really going really fast. First, of course, the cutting off of the main stage that's propelled by the Vulcan 2.2 engine. 2.1 is for Ariane 6, sorry.
La propulsion est nominale, le pilotage est calme.
Yeah, and everything's nominal. The separation of the upper stage
Acquisition de la télémesure par la station natale.
They have acquisition of telemetry through the Natal ground station, as expected.
And as you said, it's technically it's very challenging. It's not like igniting a cryotechnic stage on the ground. You have to do it in space with very, very particular thermal conditions. And of course, you're in 0G, so your propellant might go everywhere.
Yeah.
Well, thank you, Mathieu. Now we're waiting for Tamara Tezelé, the Range Operations Director, to confirm the next important steps of the mission. So we have...
Propulsion est nominale.
Propulsion is good on the core stage.
Everything is going nominal.
Well, that
the trajectory
is very
nominal.
important.
The launcher is behaving like...
Yep, they're in the track. Everything seems good here.
It's very important.
And I cannot believe that the sky was so clear that we could see.
I know, we still haven't kind of quite got over that. That was wonderful.
Stand by for extinction of the EPC.
We are now looking forward to the cryogenic main core stage cutoff. Yep. And then there is a series of other... We'll lose the signal at Galileo. The cryogenic main core stage separation.
Yes.
Do you have any news in your earpiece?
We're waiting for the
3D images are showing.
Séparation EPC.
Okay,
so
core stage separation is confirmed.
The stage is confirmed, and we are waiting for
L'image ESC.
what was just said, the ignition of the upper stage. So that's a very important step.
We're halfway there.
Yeah,
so all going...
Yeah, we're going
according to the plan.
So far, so good. All is going to plan. Well, I'm very happy about that.
Not halfway there.
Well, Ariane is heading for a geostationary orbit 36,000 kilometers from Earth. Is this a fairly standard mission for you? What is at stake?
They have an acquisition.
We are used to
loss of signal from Galileo,
orbit, but every mission is very unique. It's the satellites are different. The trajectory is slightly different. The performance of the launcher is different. And it's years of work for all the team, for the satellite team, for the manufacturing of the satellite, the launch contract signature, typically 2 years before the launch, and then all the mission preparation, especially on the launcher side.
Yes,
La propulsion est nominale, le pilotage est calme.
Yeah, it's only a 40-minute launch, but of course it took years and months of preparation upstream, and you only see the accomplishment and the result of a lot of things that were manufactured, integrated perfectly.
Well, congratulations to all your teams. Thanks. We will continue to follow this mission very closely until the separation, which we're all waiting for, with bated breath, of our 3 satellites. Galaxy 35, of course, will be the first of our passengers to separate from the launcher in roughly 20 minutes from now, followed closely by Galaxy 36. Then it will be the turn of MTG I1's turn. Well, guys, we will be living these exciting moments. I will be living these exciting moments with you, both live. But for the moment, let's look to the future, and a not so distant one. We've already looked back at the career of Ariane 5, but what is the latest news on the much anticipated launcher Ariane 6? I'm sure you're all, like me, dying to hear the latest news. And so I'm turning to Mathieu, who will give us all the answers with these new images.
Yeah, it's been an exciting year on Ariane 6 for the ESA, Arianespace, Ariane Group, and CNES teams with the preparation of what we call the combined test. What you see there are a fully representative version of the launcher with the upper stage and the lower stage that were integrated in Kourou, and you can see that now the operations are performed horizontally, and you can see how easy it is almost to join these two launchers. In parallel, we prepared also fully representative mock-ups of the boosters of Ariane 6 that you can see there.
Alex,
by the way, one of
say?
them is fully filled with sugar.
Sugar?
Yes. That's,
you're kidding me.
Yeah, we will not ignite it otherwise. So once the two stages are integrated together, they've been transferred horizontally, and you can see that at the end of the road, our road to space on Ariane 6, you've got this new mobile gantry that will be on top of the launch pad of Ariane 6. We now do the integration of the launcher directly on the launch pad. Operationally, it's a really game changer for us. It will ease everything. And we only go vertical once we are on the launch pad. So you can see this very first time we rehearse this operation, and everything went very smoothly, nominally, as we say.
That's good to know.
You hear a lot about nominal. And now we're ready to perform combined tests, which is really when the launcher meets the launch pad. But in parallel, we've got also a very, very important test campaign. Now we're in DLR facilities in Germany, Lampolishausen, where we ignited for the first time a fully representative upper stage with a Vinci engine for 45 seconds. And we've got more tests to be performed. And finally, something's missing on top of this launcher.
What is missing?
You must have recognized it, is our brand new fairing, 20 meters high. Yes.
Okay.
And you see the last rehearsal was really to check that we can hoist correctly this fairing on top, and there again, everything went very smoothly. And yes, I'm always very impressed with this mobile gantry. It's about the weight of the Eiffel Tower, except that you can roll it back when you need to launch. But,
all I know is we are all waiting impatiently for it to make its inaugural flight.
They have acquisition through Ascension.
Look at this final image that we managed to get at the end of this year. Yes.
Well, as Ariane 5 picks up speed to climb higher and higher, it continues its flight path with 3 very special satellites on board, including MTG I1,
normal,
as you know, the
trajectory
3rd generation
is
Meteor satellite built by Thales Arianespace, with monitor climate and weather changes in Europe and Africa. Now, to show the strategic importance for the African people of such a launch, Ariane 5 has taken off, as we mentioned earlier, decorated on its head, on its fairing, a unique work of art. That is why the Flight Tonight VA259 has been baptized state-of-the-art. This artwork is part of ASAP, the African Space Art Project. And to find out more, let's watch this next project. Report. Under Ariane 5's fairing is MTG I1, EUMETSAT's new weather satellite. On the other side of the launcher's cone shape, memory of today, memory of the future. This is in fact an artwork created by 3 African artists. It is part of the African Space Art Project, ASAP. This painting symbolizes the link between the European operator EUMETSAT and the African continent.
Through this artwork, the artists have demonstrated a link between Africa, space, and climate change. These 3 things are at the heart of what EUMETSAT is about. I'm incredibly proud that EUMETSAT has been a part of this project.
The collaboration between these 3 artists, Geraldine Taubé, Michel Ekaba and John David Encott, is also a tool to raise people's awareness about Africa's climate challenges.
C'est quelque part la signature artistique, symbolique, historique du continent africain qui va créer une relation tout à fait particulière avec l'espace parce qu'il a besoin d'observer de l'espace le changement climatique qui l'impacte de façon très très forte alors que c'est le continent qui aujourd'hui émet le moins de CO2 dans le monde entier.
Pour nous, l'art était une manière de faire passer tous ces messages en même temps. À la fois, ces satellites vont répondre à des besoins vitaux, et à la fois, c'est aussi un signe d'une innovation technologique et d'une aspiration de l'Afrique d'avoir un vrai rôle dans tout ce qui est spatial.
Selected by a jury including representatives of EUMETSAT, Arianespace and the African Union, the collaborative artwork carries a message of hope, harmony and sustainability.
Une chose que je retiens quand même lors de ce travail, l'impossibilité a permis le possible. D'où justement aussi le titre de cette œuvre, Mémoire d'aujourd'hui, Mémoire du futur. On a l'impression que nos différences ne nous permettent pas réellement de faire des choses. Mais justement, ce sont ces différences qui font la force de ce que nous sommes aujourd'hui. et qui apporte un plus dans le développement du monde dont nous rêvons.
A world where space is used in a sustainable way to support the Earth and prepare for tomorrow. What an interesting report. Well, Raphael, is this the first time a work of art adorns the fairing of the launcher?
Well, usually you have company's logo on the fairing, which is good, but now we have an artistic dimension to it, to the launch. The project dates back to 2018, and I had the chance, actually, the team had the chance to see the piece of art 3 meters long when it was exposed in Arianespace's offices before it got installed on the fairing. But I think this is not the first time that the Ariane launcher is involved in artistic projects.
Yes, no, but because this launcher is not inspiring engineers like me only, but also artists. And we've set up very, very interesting collaborations with some of the artists. For instance, I'm wearing an Avenir hoodie, which is actually from the French singer Orelsan.
I noticed the T-shirt.
Yeah, and it's directly...
I look forward to my T-shirt and my sweatshirt afterwards.
Yeah, we'll talk about this later.
Okay, we'll talk about it later.
But it's directly inspired by what we do, and also for the 40th anniversary of Ariane, we got an entire album composed by a musician.
Wow.
Very inspiring music.
That's brilliant.
Yep.
Well, let's get back to our mission at hand, guys. In about 15 minutes, as you know, MTG-I1 will separate from our launcher. This exceptional satellite built by Thales Arianespace for Maxar will eventually revolutionize weather forecasting. It will be placed in geostationary orbit. But, Raphael, I have a question. I thought that geostationary orbit is mainly populated with telecommunication satellites.
No, it's true that with Ariane 5 we are used to send telecommunication satellites on the geostationary orbit, dedicated to broadcast, broadband connectivity, and many more applications to connect each other. It is indeed not every day that we launch an Earth observation / scientific satellite on this such distant orbit. The asset of the geostationary orbit is that it covers a large surface of the Earth, because it's like 36,000 kilometers from the Earth. So you have like a global view, so you can measure like in a global scale for MTG lots of things happening in the atmosphere. And as a matter of fact, you only need 3 satellites to cover the whole surface of the Earth in this geostationary art. And we will launch with Ariane 6 2 more MTG satellites, new generation of MTG satellites, the S1 and the I2. This is going to be with Ariane 6.
Well, before we go on, in order to be able to properly exploit the numerous data from the exceptional satellite, Meteosat had to train its users, and there are many of them. More details in this next report, Next Tech, EUMETSAT. MTG-I1 will soon start a new mission, revolutionizing nowcasting of high-impact weather in Europe and Africa. The first data to be collected will considerably improve our daily life. EUMETSAT carefully trained and prepared future users to achieve these results.
We'll have 50 times more data coming from the new satellite compared to what we have now. So we need to handle all this data and make it accessible.
EUMETSAT is playing a crucial role to ensure that the data from MTG satellites will help to protect people and property as fast and as efficiently as possible.
Based on the new data, we'll be able to issue more precise warnings of severe weather. That saves lives, that saves journey time on your motorway, that saves transport costs, that saves airport costs. It also saves costs related to flooding, for example. So we'll be able to save lives and property based on better forecasts at the very short term, which means in the next hour, in the next 2 hours, in the next 6 hours.
With its brand new technology, MTG satellites will provide key data for the years to come.
Some of the data has new information in it which we don't have from other geostationary orbits over Europe, and that's really very exciting. We are not having that from anywhere else.
It's European satellites. It is better satellites than we had before. They have a higher resolution, which means that we can see more details in the images. This is all very exciting because it brings a lot of potential, a lot of new possibilities.
This data will also be an important source of information for the aviation field, where nowcasting is essential.
If the visibility goes very low or the cloud base gets very low, they need to do different kind of procedures. They cannot have so many planes moving on the airport, and they kind of need to get ready for that one. And then the nowcasting comes in, and we try to warn their airfields about those things.
After years of preparation, MTGI-1 is now on its way to geostationary orbit to help us all to better anticipate tomorrow's weather. MTGI-1 is on its way.
Hey, we got the telemetry back.
To
That's
destination at 36,000 kilometers from Earth. It will be put into orbit in a little over 10 minutes now. But before that, our launch has to complete a number of important steps. Raphael.
I mean, the first one is the cutoff of the upper stage engine to prepare the first satellite separation, Galaxy 35. It is very important to do it on time because it's really driving the satellite injection accuracy, and it has an impact on the rest of the satellite lifetime in space.
Yeah, 1 second too early or 1 second too late, you're not on the same orbit.
I imagine.
Yeah, and I mean, Ariane 5 had a reputation for being very precise because last year, when we injected very precisely the James Webb Space Telescope, it allowed the telescope to double its life expectancy in space because it didn't have to use as much as propellant to reach the final orbit. So from 5 years to 10 years of operation.
Okay, so the second stage is, or well, third stage, I suppose, is everything seems to be going good here. I mean, there was a little bit of time there without the telemetry, so I couldn't really say what's going on. But other than listening to the mission director's calls, but everything seemed good there. But once again, they're not showing the telemetry.
Very fast. You know, the first event is really we separate these cryo arms that are that are fitting the upper stage. Liquid oxygen, liquid hydrogen. You ignite.
They have an acquisition of signal through Malindi.
Everything's ready. You can ignite the solid propellant boosters, and it's liftoff.
And those pieces that are coming off are FOD covers, guys, to make sure that no debris gets inside of it when they move the rocket to the pad. So that's all normal. Everything looked good. It was a great launch. Great visuals. Great visuals. Oh yeah, really, really nice. Launching in the afternoon gives you really, really good color.
I
didn't see it, Cam. I'll have to go look.
What a show.
Well, in a moment, Ariane 5 will acquire the signal from Malindi in Kenya.
She just said that. No, never
with
mind.
a much-awaited countdown to the separation of the first Galaxy 35 satellite. Is it not, Raphael?
Yeah. So there are lots of concentration. Right now we are like raising altitude quite drastically. So we are at a speed of about 9 kilometers per second.
Yes.
So it's quite fast.
No,
we are flying over Africa right now. And so lots of concentration before the last steps. Because like I said, it's a combination of years of work from all the teams.
Yeah, but imagine that in less than 30 minutes, we managed to fly over the Atlantic Ocean and now over Africa. We're really standing on the east coast of
That is just
Africa.
quite incredible.
Yeah, but that tells a lot about the orders of magnitude that we're dealing with with Ariane. I told you the velocity we'll reach is higher than 33,000 kilometers per hour.
Tous les paramètres à bord sont normaux.
Was it easy assembling
Parameters are normal. Guidance is working correctly.
For this flight?
It'd be nice to see some telemetry, though.
A meeting of two different worlds with telecommunications satellite on one hand and Earth observation / scientific satellite on the other hand. So they have different constraints, and especially on the cleanliness aspects. So we had to be very careful in actually preparing the satellites in the clean rooms and during the encapsulation under the fairing, because you know that one single speck of dust.
I'm sorry, guys. I'm just gonna say it. How can you have a cast about a rocket launch and not show what the rocket's doing? Come on, guys. Come on.
Yes, we were waiting for this
Tamara
confirmation.
says, Lay, she's just what she just told us.
Yes, that's the upper stage has been cut off. It means that we've reached our final orbit. So now we're entering another phase.
Are we in the ballistic phase?
The space ballet.
The space ballet.
Yeah.
I love that
Yeah,
term.
the upper stage is like performing slight orientation maneuvers to separate the first satellite in a specific direction. But we'll see also different maneuvers to be realized in between each separations in order to make sure that there is a right distancing between the satellites in order to prevent any collision.
Yeah,
of
I
course.
know it's hard. It's
Well,
a
in
lot
1
to
minute,
ask,
of
I
course,
guess.
There will be the separation of the satellite G35. Thank you, Raphael. We're all waiting eagerly en route to space for this separation. This C-band telecommunications satellite was, of course, built by Maxar for Intelsat. Until then, what are the final important stages that we should be all looking out for?
Well, I mean, we will witness the separation of Galaxy 35, quickly followed by the separation of Galaxy 36. Then we'll have the separation of the dual launch structure, the SILDA, which is the black box right under it. And then we don't see it on the image, on the 3D image, but there is the MTG I1 that is going to be separated in the final stage. And then the mission is not over for Arianespace, because we perform passivation of the upper stage, and then it's going to be the end of the mission.
And separation should be right now for Galaxy 35. We're waiting for the confirmation.
Séparation G35.
Okay, so it's half a relief for the customer now.
Confirmed. Happy faces, thumbs up.
You see
Everyone's
happy faces,
smiling.
but also concentration,
Yeah.
because
Thank
it's
you.
definitely not over.
Yeah.
Now let's head to the fishbowl where we should be able to see, well, I don't know who he is, but Valérie Boucher, she is Intelsat project manager at Arianespace and the person who coordinated all the internal activities to ensure that the launch went smoothly. It must be such a relief for her when I wouldn't even want to be in her place. But this is, of course, not the end of the mission, is it, guys?
No, it's not, because like we said, like there are like many separations to come. It's also only for the customer the start of the journey, because they have to check that the satellite is doing perfectly, and also to bring the satellite from 1,000 kilometers from the surface of the Earth to 36,000 kilometers. So the journey. So this is
we have
Valérie
Valérie
Boucher,
Boucher, Intelsat project manager, and of course before we had Tamara Tesley, who is the Rangers, the DDO, the Rangers Operations Director. Good evening, Valérie Boucher, and congratulations. Galaxy 36 is just about to be separated from Ariane 5, joining its brother Galaxy 35. Raphael, the first 4 satellites of the Galaxy constellation built by Maxar for Intelsat are not positioned in the same orbits. Why is this?
Well, I mean, they are quite close to each other. They're all positioned on the geostationary orbit, and they're all facing the North American area, which is like a quite big one. So in order to cover everything, you need several satellites to be placed like on this geostationary orbit in order to provide services also for remote areas. We know that in the US there are lots of deserts, mountains, so satellites are key assets to be complementary to terrestrial solutions.
Well, it's time to take a look at what's going on some 600 kilometers now above our heads. What is the status of Ariane 5? Raphael, I think we're waiting for the separation.
Yeah, and you see that we are still
GTO
raising
insertion.
altitude. We went from 940 kilometers to 1,500 kilometers in only 3 minutes. And we are now about to witness the separation of the second upper stage passenger, Galaxy 36.
G36.
Yeah, in about 30 seconds. Just to give you also another order of magnitude, keep in mind that the International Space Station orbits
the
Earth at only 450 or 400 kilometers. So we're way above it.
And before each flight, we make sure that we don't collide with the ISS, which is very important.
Okay.
That's part of the calculation.
Nothing is left to change.
Well, of course, we have our DDO, the Range Director's
G36.
Tamara Tesley up on the screen, who is about to announce any minute. 4 seconds.
Séparation G36.
Okay, good separation from the mission director there.
Now we see happy faces.
Next
Happy
thing
faces again.
for the
Brilliant.
upper passenger.
Oh my god. All right. The next phase in the flight is jettisoning the Silda. Silda is basically a structural component that's shaped like a cup, and it has a payload attachment fitting at the top for a satellite to go up there. But what it does is it basically separates, and inside of that cup is another satellite. So in this particular case of this Ariane mission, you had Galaxy 35, Galaxy 36. You just saw 36 pop off there in the animation. And now the next thing is the upper stage will orient to a radial orientation relative to velocity, separate Silda, and then that opens up the door, literally, to have MTG-1 separate. Galaxy 35 and Galaxy 36 are Intelsat communication satellites for the North American corridor. I shouldn't say North American corridor. That's not really the right way to say it, but... and MTG is a climate monitoring satellite. They've stacked three of these things on top of each other. Two of them are stacked on top of each other on Silda, and MTG is stacked inside of Silda. If you notice, they reorient this stage to radial in, so basically the stage is pointing down, so they get a good separation of Silda, and then, if I'm understanding this right, they'll reorient to deploy the satellite in a different direction.
Wait for this confirmation that it occurred.
Not everybody stacks
We're
three
waiting
big
for the
satellites
DDO.
on top of each other, Velk. It's actually a pretty cool capability. I kind of wish they would talk about it more, but whatever.
And you can really see on the animations there.
Séparation Silda.
Silda separation.
All right. So confirmation that
Brilliant.
Silda has been successfully separated, and you can see that we are still gaining lots of altitude in 2 minutes. We've gained we have now come close to about 2,000 kilometers of altitude.
My question is there going to be a Silda on Ariane 6?
Yes.
That's what all my space friend geeks want to know.
Yes, we will still need to perform some dual launches or triple launches as we have today. But we have a new dual launch structure, a new DLS, that will be actually larger and higher. So now we can really accommodate bigger satellites on top and below the DLS.
It helps us to propose many different...
Can I just interrupt you? We have now Sébastien Lemay in the fishbowl. He is EUMETSAT's program director for Arianespace. Good evening. Sorry, I interrupted you.
No, I was saying that we have lots of configuration that we can imagine under the Ariane 6 fairing. This is probably also why we have been so successful in selling Ariane 6 so far, because we sold 28 Ariane 6 already, including 18 for famous constellation. So we are really looking for the first flight of Ariane 6.
I got the message, Raphael.
With only a few seconds to go before the separation of NTG-I1, everyone must be holding their breath now. I'd like to remind you that NTG-1 is the first of 6 satellites dedicated to weather forecasting. We are now waiting for the DDO, Tamara Tesley.
The animation is not synced to the mission timeline, so...
Séparation MTG-I1.
Brilliant. I want to applaud with them.
All right, that's the end of the mission. Cool. We're good. Everything's good. We don't need to ever watch this ever again. Ever. Again. Ever. Actually, if you guys do want to know, I was timing it they started picking up the count at T-minus 23 minutes. 12 minutes of that was showing the rocket. 12 minutes of the countdown, 23. So that's not bad. During ascent, though, we're T plus 35, 38, and I know that Ariane doesn't have any onboard cameras, so I counted any time they were showing the telemetry. Mission timeline, we're T plus 36 minutes in now, and they showed 15 minutes of telemetry. So More than half of the time of the rocket ascending, we didn't see telemetry. We saw something else that wasn't the rocket. Now, don't get me wrong. Half and half is okay. It's okay. But also, it's, I mean, no onboard cameras, which, I mean, once again, hey, if it does, Ariane 5's old school. Delta 4 doesn't have many onboard cameras for the same reasons, because it's old. I thought I'd keep track of it just to see. So, and I separated it into 2 columns. So like before launch and after launch. So like after launch, we saw about there was about 15 minutes of the launch with no telemetry. So I'm counting the telemetry because it is real time. I'm counting that as, you know, the rocket, right? Because it's real time. You can see what the rocket is doing. So that means about 15 minutes of this cast post-ascent had nothing to do with the rocket, and we couldn't see the rocket. I'll admit that's better than in the past, but man, it's getting better, Cammy. It's better than it was.
Discovery, go at throttle up.
Yeah, they really need... They were showing replays of the rocket launch without the telemetry from the rocket that launched that they were watching replays of on. Merry early Christmas. You too, Maverick. Merry Christmas. Did you count how many times the host talked over the person answering the question? I lost count at 8. Aqualux. I lost count. I was keeping... Okay, let me put it to you like this. She started interrupting, and then I decided to keep track of it. And I counted 8 times before I just said I'm not doing this anymore. So maybe she did it like 3 or 4 times before I started keeping track. But yeah. Can we just have Raphael, the guy with the rocket, the blown up diagram of the rocket on his shirt? Can we just have him host the cast, please? Raph did Arianespace cast once. He casted the whole thing, and it was great. It was the best launch stream we've ever seen, because Raph's an engineer and he's gung ho about flying stuff into space. And I said it at the time. I'm like, Raphael just needs to host every stream. Yeah, he just needs to host. He just needs to host every stream. Like just him. Like it's this guy. It's this guy on the left. And yep, we went back to looking at the lady.
Important officials from EUMETSAT, ESA, and Thales Alenia Space. There is Phil Evans, Director General of EUMETSAT, Simonetta Kelly, Director of Earth Observations at ESA, and Hervé Deret, CEO from...
Okay, I can't do this. I can't do this. I can't do this. I can't do this. What is it with today and everything being cringe? Stop being cringe. It's cringe. Oh! Stop being cringe. Stop it. Stop doing that. You're cringe. I know, but I do it ironically. Stop being cringe. Stop it. It's corn. It's got the cringe. You know it's cringe gift subs. It is. Lunprod, someone redeemed garage stretch breaks, so let's go do that. My blood pressure. Nah, I'm just kidding. I'm going over the top for comedic relief. It wasn't a bad cast. That was okay. It wasn't too bad. I just...
Discovery.
Oh, no.
Discovery, go at throttle up.
Thank you. Dude, you gave enough. You don't need to do that, man. Damn. Oh, okay.
Discovery, go at throttle up.
Let's fix the snowblower. You want to do that?
Discovery, go at throttle up.
Maverick. Oh no, thanks for the 20, man. And Matt, thanks for the 2. How about some guitar practice? I don't have my guitar. My dad took it. He took it because he wanted to restring it. Hokey. Oh man, you're killing me. You're killing me.
Discovery, go at throttle up.
Oh boy.
Discovery, go at throttle up.
They could do what Astra did and hire Tim to host the stream. I believe it was Firefly that had Tim host the stream, Neuro.
Discovery, go
Astra
at
had
throttle up.
NASA spaceflight, if I'm recalling correctly. We got to do a shakedown mission, Jack. Yeah. Evil Rays, hey, thanks for the raid. All right, we will garage stretch break. We need to decompress, and then we'll get to Kerbal.